is the basic graph of sine. This is what the graph looks like. But when the graph has a period of 2 pi, it looks like this, with the shape of an N.
What does it represent? The sine function has an up-down curve. These curves that follow the shapes are called sinusoidal waves. Why is it called a periodic function? Because it repeats its values in regular intervals or periods.
We were given a sine function, as you can see, because here we have the sine. It has an amplitude of 2, here is a 2, and the y-intercept is of -1, so that's why we graphed it from -3 to 1. We have a period of 4 pi because we have it from -2 pi until 2 pi. And the endpoints were given with the y-axis and the periods.
Brian has been checking his heart rate for several consecutive days with an application, and the information is saved in his phone. He concluded that his heart rate behaves in a periodical form because he discovered that even if it varies within each day at the same time during several days, his heart rate is practically the same. The highest heart rate that he recorded was 90 bpm at 3 p.m. and 12 hours later, the lowest was 60 bpm. Determine amplitude, period, Brian's heart rate at 11 p.m. Body, the sine function that models the situation, and sketch its graph. First of all, we know that it's a sine function because they're telling us. Then we need to gather all the information so we're able to do and to graph the problem. So we have that the highest was 90 bpm and the lowest was 60 bpm. We have to get the median so we can get the y-average value. That means max minus mean divided by 2 plus mean. And in this case is 90 minus 60, 30, divided by 2, 15. 60 plus 15 is 75. So we have our y-average is 75. Our amplitude is 15 because 60 plus 15 will get you to 75. And our period, here they are telling us that 12 hours, it's the time from the highest to the lowest. But we don't have the complete sine function, so we need to add the complete day so we can rise again and complete the other part. So we have our period 12 hours. We know that the formula for period is 2 pi over b. We leave the b alone and we have pi over 12. We will use this later. So we start graphing. We graph from 12 p.m. a whole day to 12 p.m. and we will need this part later. So we registered that at 3 p.m. the highest was 90. So we have our peak in 90. And then we have that at 12 hours later, so that means 3 a.m., we have the lowest. So if we don't have this, it's a simple line. We're missing parts. How are we gonna get that? Well, you count the spaces from 3 p.m. to 9 p.m. And how do we get 9 p.m.? Well, is the half of 3 p.m. and 3 a.m. You count this part, and this part must exactly be this part. Why? Because you have to have like a pattern. And at this 3 a.m. you also completed at 9 a.m. So if you notice, we have 9 p.m., 9 p.m., 9 a.m. And this is the equation, and this is a graph that sketch this problem. So how do we get the equation? Well, you just plugged in all the information we just gathered. Y equals 15 sine, our period that is pi over 12, parentheses, x plus 3, y plus 3 because you're moving 3 to the left, and that's why it's plus 75. Okay, 75 because it's a y-average value. You can do FOIL or you can leave it like this, and FOIL, this is a new equation. So what will be Brian's heart rate at 11 p.m.? Okay, you just plugged in 11 in the X, but you must be sure that your calculator is in radians or you won't get the answer. And here we check if it makes sense. We have 11 p.m., 9, 10, 11. Here, 67.5. Yes, it makes sense. Because it's falling until 3 p.m., then it's in 60. So that's how you get this problem. And I hope you understand it.
Okay, so this is another example of a sine function application. So here we have the graph, and here we have the equation, and the problem is San Francisco Bay is an inlet of the Pacific Ocean. At a dock, the depth of water is 3 feet at low tide at 2 in the morning, and high tide is 71 feet, which occurs every 5 hours. Draw a graph showing the depth of the water and write a function. So here we can see the equation representing all the numbers that the problem has and the graph, and we can notice that it is a sine function because of the shape of the graph, which is like an N shape.
In my opinion, I really enjoyed this project because it was different and fun, and also it made me remember everything about the topic. We worked perfectly as a teamwork and we had no trouble at all. I love doing challenging but interesting projects.
Personally, I really enjoyed this project because it was challenging for me and I had to research and ask for help to be able to solve the problem I was chosen to. We did a very good teamwork and it was a good way to close a semester.
In this project, I fully understood sine functions by graphing and understanding word problems.
I really appreciated this project because it was based on a question and answer format, and that's easier for me to understand. I got to recap the different topics of sine functions and now I understand it perfectly.
This project was really fun and interesting to do since we were assigned a topic we saw before that I understand perfectly.